Hello and welcome to my last video of the week and also the last video of my little Logarithm Week series. In this final video of the Logarithm Week, we are going to solve this logarithmic inequality. First, whenever you are dealing with logarithmic functions or equations or inequalities, you must always check for the conditions for the base and the argument. So the condition for the base is that x squared must be positive and x squared cannot be 1. And the condition for argument is that absolute value of x plus 2 must be positive. And from these, we obtain that x cannot be 0 or plus minus 1 or minus 2. So with these conditions in mind, now let us change the base in this inequality. Again, let us use the common logarithm. Then we can write log base 10 absolute value of x plus 2 over log base 10 of x squared on the left hand side, and this is less than 1 over 2. Here the next process is of course multiplying log of x squared on both sides, but we must be careful here because in the process of multiplying this, we have to consider its sign, which decides the direction of the inequality sign when it is multiplied on both sides. So first, let us think about the case when x squared is larger than 1. This means that log x squared is positive, so the direction of the inequality sign does not change when we multiply this on both sides. So we have log absolute value of x plus 2 is less than 1/2 log x squared, which we can also write as log x squared to the power of 1 over 2. And if we remove the log on both sides, we have absolute value of x plus 2 is less than x squared to the power of 1 over 2. Now both sides are positive. I have already said that x cannot be minus 2 because of the argument condition. So since both sides are positive, squaring both sides does not change the direction of the inequality sign. So if we square the both sides, we have x plus 2 squared less than x squared. So if we expand and cancel out, so we have x is less than minus 1. Now we have to find the common range between this and this x squared greater than 1 and this condition of base and argument. So we have x is less than minus 1 right here, and this range automatically satisfies x squared greater than 1. And we have to exclude these values, so this minus 2 here is excluded from the solution. Therefore, we only have this range. So we have x less than minus 2 and x is greater than minus 2 and less than 1. So this is the solution for case 1. And the second case is where x squared is less than 1, which means that log x squared is negative. Therefore, the direction of the inequality sign changes when log x squared is multiplied on both sides. So we have log absolute value of x plus 2 is now greater than 1/2 log x squared. Again, we write this as this and remove the logarithm. And again, since both of them are positive, we can simply square both sides without having to change the direction of the inequality. So we have this, and now we have x is greater than minus 1. So now we have to find the common range between this and our base and argument condition. So we have x greater than minus 1 right here. And since x squared must be less than 1, x must also lie in between minus 1 and 1. And then we have to exclude 0 from our solution. So we have this range as our solution. So we have x is greater than minus 1 and less than 0, and x is greater than 0 and less than 1. And this is the solution for case 2. And if we combine the solution from the case 1 and the case 2, we have our final answer. X is less than minus 2, x is greater than minus 2 and less than minus 1, x is greater than minus 1 and less than 0, and x is greater than 0 and less than 1. So this is our final answer. So x can have these values excluding the boundary value of 1 and 0 and -1 and -2 as well. So that was all for this video. I hope you enjoyed it, and I will see you in another video.